Basics of hypothesis testing. Recall that there are two main branches of statistics. We talked about this way back in Chapter 1. First, we learned how to summarize our data with frequency tables, charts, and graphs, and we also calculated statistics such as mean, median, mode, range, standard deviation, and variance. That branch, or this branch of statistics, is called descriptive statistics. So all we do with descriptive statistics is organize and describe our statistics. We don't do anything to mess with it. We just kind of collect it, organize it, and try to see any trends. Then we moved on to making an inference, conclusion, or decision about our data called inferential statistics. And the first thing we learned with inferential statistics was how to estimate a population parameter with a confidence interval. So we were able to say with a certain level of confidence that this interval here contained the true mean or the true proportion that we were interested in. We go further into inferential statistics in this section, where we will test a claim or hypothesis about a population with the method of hypothesis testing. Now, there are specific methods to hypothesis testing depending on whether you're testing for the mean or the proportion or the standard deviation of a population. And we'll get to those specific tests later. This section is mainly made up of the basics of hypothesis testing, and these are all things that are the same across the board no matter what test you're doing. So we're going to work on those first before we get to the specific tests for specific things, parameters that we might be testing. So the first thing you do in any hypothesis test is to state the null and alternative hypothesis. When considering a particular situation, the null hypothesis is usually a claim or specification about a population parameter, again either the mean, the proportion, or standard deviation, that has historically been in place, meaning it's been this way for a while, or this is how we think it is right now. Almost always, the null hypothesis will state that the population parameter is equal to some stated value. So perhaps we think the average salary of college professors is $60,000, or another parameter might be we think the proportion of high school seniors that go on to careers in the military is 10%. Those are claims we might hear stated in the null hypothesis. There's an equal sign there. You'll also sometimes see the null hypothesis stated with greater than or equal to or less than or equal to. Even with an inequality, the or equal to part is still part of the null hypothesis. So whether it's strictly equal to, greater than or equal to, or less than or equal to, there's some type of equality that will be included in the null hypothesis. Notationally, the null hypothesis is denoted by H sub 0. You'll also hear that referred to as H naught. Then, any statement or hypothesis that mentions the population parameter being different from the null hypothesis is called the alternative hypothesis. This is usually the claim we are trying to prove in order to reject the null hypothesis. So maybe we believe that average salaries for professors are higher than $60,000, or they could be lower. We might say that the proportion of high school seniors going off to military careers is less than 10%. So if we're saying something that's other than what's stated in the null hypothesis, that's going to be the alternative hypothesis. The alternative hypothesis is denoted by H sub 1, and it's going to be stated using either strictly greater than, strictly less than, or not equal to. Notice that our inequality symbols here don't have the or equal to bar underneath them. So anything with equality is going to be in the null hypothesis. Greater than, less than, or not equal to will be in the alternative hypothesis. Let's take a look at an example to see if we can get an idea of how to state the null and alternative hypothesis. Example 1. A television network states that the average length of time devoted to commercials in a single hour of programming I have an extra of there, is 14 minutes. Viewers feel that commercials take up more than 14 minutes during a programming hour. State the null and alternative hypothesis. So here, H naught or H sub 0, we might say average, and for average means that refers to the mean, so I'm going to use the notation mu. We're saying that, or the network rather, is saying that, yep, commercials are 14 minutes per programming hour. But maybe viewers say, no, I think they're a little bit longer, so that would be the alternative H sub 1, and we would say that mu is greater than 14 minutes. So that's one way we could represent this situation with our hypothesis statement. Another way you might see this exact same scenario represented is the alternative is still saying, we think it's longer than 14 minutes. But some books and some authors might state the null as saying less than or equal to 14. So it's opposite of whatever the alternative is. For that reason, some students prefer to write the alternative statement first and then go back to figure out the null, which is perfectly okay. But both of these are correct, and sometimes it just depends on the author or the textbook or the publication. Example 2. A newspaper article states that the proportion of traffic accidents involving texting is the same this year as it was last year when it was 9%. Suppose we doubt this statement and want to carry out a hypothesis test to see if we can refute the claim. State the null and alternative hypothesis. So the article, or H sub naught, the null hypothesis, is saying that traffic accidents are 9%. Notice that we have proportion here, so I'm not going to use mu as my notation. I'm going to use P for proportion. So the newspaper is saying that it's the same this year as it was last year, that P is equal to 0.09 if I change my 9% into a decimal. The alternative is we don't think that's right. Now what's missing here is there's not some quantifier to say that it's more than 9% or that it's less than 9%. We just believe it's not 9%. So the way we would represent that is to say that P is not equal to 0.09. Once we have our hypothesis stated, we want to move on to what type of test we will be conducting. While the null hypothesis will always state the parameter of the population being equal to or greater than or equal to or less than or equal to a specific value, the alternative will state that the parameter is less than, so there's your less than symbol, or more than, or not equal to that same value. The statement in the alternative hypothesis will determine which type of test we are conducting. So it's important that we get that one correct. Now if H sub 1, remember that's the notation for alternative, if H sub 1 states that the parameter is less than, then it is a left-tailed test. So we're interested in the possibility of values being smaller than the stated value, so that's going to be a left-tailed test. If H sub 1, the alternative hypothesis, states that the parameter is greater than, then it is a right-tailed test. And finally, if H sub 1, the alternative hypothesis, states that the parameter is not equal to or different, then it is a two-tailed test. Okay, so in reference to that, let's take a look at example 3, which is asking us to look back at examples 1 and 2 to determine which type of test should be used. Now, example 1 was about our commercials, and the alternative commercial, or not commercial rather, the alternative hypothesis said that mu is greater than 14. So what type of test is that going to be? Well, since we're thinking that commercials are longer than 14, maybe they're 15 minutes or 15 minutes or 30 seconds, that is going to be a right-tailed test. In example 2, we were talking about the proportion of accidents due to texting, which I hope none of you are doing that. And the alternative stated was that the proportion was not equal to 0.09. So remember, we didn't have a direction specified. We couldn't say whether it was greater than 9%, less than 9%. We just don't think it's 9%. So this would be a two-tailed test. And if I had something that was greater than, then that'd be a right-tailed test. So the alternative hypothesis, we want to make sure we get that right, because that's going to tell us what type of test we will be conducting.